So this is an example of the result of using muscle, kind of a muscle analysis program that combines the data we got from the lab, calculating the net joint moments, and then inputting it into this fairly complicated program that then calculates out for us the different muscle moments at the joint. So when we talk about a muscle moment that's being generated, we're talking about that individual's muscles contribution to the joint moments we were calculating last week when we did the sit-stand task. And essentially, what we're getting at is the combination of that muscle's PCSA and its moment arm together to kind of understand its overall contribution to that moment that's being generated. And what we have here is a simulated sit-to-stand task where the left-hand corner of each of these graphs is a fully standing position, the 50% point is a fully squatted position, and then the 100% point is a return to a standing position. And we have that for each graph on the x-axis. And then what's on the y-axis is the moment arms of each set of muscles. So we have gluteus medius maximus, hip extension moment, the adductor magnus hip extension moment, and the gluteus medius here, and then the hamstrings to the bottom right. So we can see, if we look across there, we can see the contributions to the extension moment are really different for each of these muscles. And so in essence, the hamstrings, let's focus on the bottom first. The adductor magnus has first a fairly significant moment contribution to extension, and the hamstrings, though, if we look at those, the semitendinosus and membranosus, they're almost twice as high as the adductor magnus or the glute maximus. So we come up here, this is 55 or so. The adductor magnus is 55 or so, it's a peak. The glute medius is also 55 or so, and the hamstrings is over 110. So by a factor of 2, the hamstrings is really the king in terms of its ability to produce a hip extension moment. So now we can also look at the interaction between some of the muscles. And in essence, what we can see is that the gluteus maximus peaks in terms of its interaction of moment arm and fiber length PCSA and its ability to generate a moment here at about 20% of the squatting cycle and then 80%, where the adductor magnus maintains its ability to generate hip extension moment as the hip is flexed. And so that's kind of interesting. And so it would be fair to say of all of the four muscles being evaluated, the gluteus maximus is the weakest muscle coming up from a squat when you're in terms of extending the hip joint. So another observation is important clinically when we think about the knees coming together when somebody squats. So we typically think of when the knees will come together as somebody squat that there's weakness in hip abduction, or in terms of controlling internal rotation. And so what the dotted line here is the same data of all four plots of those contributions of those muscles when you've internally rotated the hip 15 degrees. And so what's interesting is that when you internally rotate the hip 15 degrees, the gluteus maximus muscle loses some of its strength, likely because its moment arm's been decreased, because the PCSA likely hasn't been changed that much. The adductor and the hamstrings are unaffected, but the glute medius production is enhanced. And so what's interesting is instead of when the knees come together, it may not be caused by a glute medius weakness, because this is really enhancing its output, as it is perhaps a glute maximus weakness.